Good morning. My name is Tracy Ann Wellington, and I'm the Acting Head of Policy and Coordination at the Nuclear Energy Agency. Thank you for joining us for today's webinar, Powering Kenya's Future, Understanding Nuclear Energy, co-hosted by Kenya's Nuclear Power and Energy Agency, NuPEA, and the Nuclear Energy Agency, NEA. We expect that this will be the first of several informative webinars on this theme. For those who are interested in learning more about the Common Journey Initiative, the NEA's program to advance economic development and skills expansion in Africa, a QR code will appear at the end of the webinar. Now I'd like to introduce the Master of Ceremony and moderator for today's webinar, Lillian Matu. Lillian Matu is the Director of Information, Advocacy, and Communication at the Nuclear Power and Energy Agency and has been instrumental in the implementation of Kenya's nuclear power program since its inception. With over 14 years of dedicated experience, she's highly regarded expert in the areas of stakeholder involvement, public communication, and advocacy initiative within the nuclear energy implementation. She holds a master's in business administration and a degree in international relations, both from the United States International University. Ms. Matu, over to you.
To get us started and to set the scene, I'm pleased to invite our CEO, Sir Justus Wabuyabo, who is the CEO for the Nuclear Power and Energy Agency, to give an opening statement. Mr. Wabuyabo is the current CEO of the Nuclear Power and Energy Agency, which is a state agency under the Ministry of Energy and Petroleum in Kenya. Prior to this appointment, he served as the Director of Legal and Regulatory Services and Corporation Secretary. Previously, he served as the General Manager, Corporate and Legal Services and Legal Services at the National Water and Harvesting Authority. He holds an LLM from the University of Nairobi and an LLB from the Moi University. He's a certified public secretary of Kenya, a commission of oaths, and notary public. He is a member of the Law Society of Kenya, the East Africa Law Society, the Pan-African Lawyers Union, and the Commonwealth Lawyers Association. He is also a member of the Institute of Certified Secretaries and the Association of Professional Societies of East Africa. Without further ado, I would like to welcome Mr. Wabuyabo to turn on his camera to give his opening remarks.
Thank you, Lillian, for the introduction, and also Tracy Ann for opening us up for the webinar. DG Magwood, colleagues and friends, it's really a pleasure to be with you this morning to discuss Kenya's nuclear journey. As you will be hearing, this is a project that started way back in 2010, and we've steadily walked this journey following the IEA milestone approach and religiously addressing the infrastructure issues as required in such a way that we finished the first milestone and are now in phase 2 of the program, which is really critical, and because of the issues that we are facing and we see have been faced by both countries that have the technology and others that are also pursuing it, like our brothers in Ghana and Egypt and Rwanda and elsewhere in Africa. We see some challenges, and we believe that through cooperation with international organizations, particularly the IAEA and NEA, we should be able to get good experience so that as we pursue this journey, we walk the journey with confidence, noting that it's a path that has been trodden by others, and we should not have undue fears. I think through the NEA's Common Journey Initiative, we will be able to tap into the experience of NEA members on how they've been able to address the issue of stakeholder engagement to really help Kenya address its energy needs by incorporating nuclear as part of the sources of our energy, which will address both our aspirations as a country to develop economically, but also ensuring that our development is sustainable and does not harm the environment. I want to take this opportunity to thank DG Magwood and NuPEA for agreeing to work with us in this journey. And we really do not take for granted this support. And we hope that through this initiative, we shall be able to reach critical stakeholders to be able to disseminate what we are doing as an institution, and also to get the necessary support that we can get from all the quarters, especially our decision makers. And I want to laud our Minister for Energy, Honorable James Opiyo, and I, together with our Principal Secretary, Mr. Alex Wachira, who have been really supportive and giving us the necessary support to be able to move the Kenyan program, nuclear program forward. I know that we have limited time, and so I want to leave it there and really encourage all who are joining us from wherever part of the world to really participate and learn and also ask questions, because we are here to address the concerns that may be there, so that we ensure that the Kenya's nuclear program is delivered in a manner that respects the interests of the people, the environment, and also the aspirations of the Kenyan people. With those remarks, I want to welcome all to this event. Thank you very much.
Thank you for your perspectives on the role of nuclear, that nuclear can play in Kenya's future. And you have really framed well why conversations like these are important. Next on the agenda, we'll have a presentation from NuPEA, and then following a keynote address by Director General Magwood of the NEA. To introduce NuPEA and the journey of nuclear power in Kenya, we have with us Engineer Eric Ohaga. Engineer Eric Ohaga is currently the Director of Nuclear Energy and Infrastructure Development at the Nuclear Power and Energy Agency. Previously, he worked at the Kenya Power and Lighting and rose through the ranks to the position of County Business Manager. He has over 19 years of experience in energy policy development, nuclear energy policy and strategy formulation, design, construction, contract management, operations, maintenance, and planning of power systems. Engineer Ohaga has intense experience in power purchase, contract administration, and regional power trade, and participated in the development of Kenya's standardized power purchase agreement for renewable energy sources under the feed-in tariff regime. He's a fellow of the Institution of Engineers of Kenya and a consulting engineer with Engineers Board of Kenya. He holds a Master of Science in Nuclear Engineering, Masters of Business, and a Bachelor's of Science in Electronic Engineering, and a postgraduate diploma in Project Planning and Management. Without further ado, I invite Engineer Ohaga to turn on his camera and give his presentation. Thank you.
Thank you so much, and I really appreciate this engagement that we are going to have today. And I'm privileged to take the members through the journey that we've had over the last 10 years. So we'll be looking at why nuclear energy for our country, Kenya, and also delve into the progress that we've made so far in regards to deploying of the nuclear power in our country. Then we shall look at the next steps, and then we shall have a conclusion. Now, Kenya has a vision, which we say Vision 2030. And this vision anticipates that Kenya will be a middle-income economy by the year 2030. And this economy will be driven by industrialization. And there are three pillars that actually sustain this vision. The first pillar is on the economic pillar, which envisages that Kenya is going to sustain a double-digit growth for the next 25 years. The next pillar is a social pillar, which anticipates the country that will be a just and a cohesive society that derives its participation in a clean and secure environment. Last but not least is the political pillar, which anticipates that Kenya will be led by an issue-based, people-centered, result-oriented, and accountable democratic system. Now, for us to be able to achieve this very ambitious vision of improving the quality of life of the Kenyan people, then energy is an enabler to all these three pillars. And what better kind of energy can we talk about if it is not nuclear energy? Because we are talking about industrialization to be able to drive this economy. Now, when you talk about why nuclear for our country, Kenya, first of all, is because of the Vision 2030 that is supposed to be driven by industrialization. And therefore, that means we must have a source of energy that would spur economic growth through industrialization. And therefore, that requires us to have a stable baseload that is able to provide reliable energy to these industries. We're also talking about climate change, and this is a very topical issue across the globe. That source of energy that we want to bring into our grid must be a clean source of energy. And what better source of energy would that be if it is not nuclear? A very center to the people of Kenya is on affordability and cost competitiveness. And this is answered in this source of energy we call nuclear, because the life cycle of levelized cost of energy would be cost competitive. And this would then be able to lower the tariff for the Kenyan people. Now, we are also cognizant of the fact that just transition is a critical milestone that many countries are trying to achieve. And when you look at nuclear and its inclusion in our energy mix and the effect that it has, Kenya has really committed itself to the nationally distributed contribution, and we have committed to do that at 32% reduction in emission. Currently, we have the business as usual, which stands at 143 metric tons of CO2. And out of these, 31 metric tons come from the electricity sector. Now, when we do our simulation with the inclusion of nuclear and a vision scenario, which is a more ambitious scenario, where we are saying that we want to industrialize by the year 2030, then if we include nuclear energy mix, that means we shall reduce CO2 emission to only 0.912 metric tons by the year 2043. If we use the reference scenario, which is the planning scenario, then we shall reduce the CO2 emission by 0.01 metric tons. Now, if we use the lower scenario, then the contribution in terms of emission of energy would be almost zero in that regard. Therefore, this just transition in terms of contribution of nuclear energy in our energy mix, therefore defines the importance of this source of energy in the just transition to reduce the greenhouse gases in our energy mix. Next slide. Now we want to look at our Kenya demand and projection. And we do our planning, which is a 20-year plan that we call the least cost power development plan. And we have projected our demand to grow to 8,153 under the reference scenario. But under the vision scenario, we shall grow at 13,000 megawatts, and the low scenarios at 5,000. So according to this plan, therefore, nuclear has been planned for the year 2034, which is on the generation projection. And you can see the generation mix in our country consists of clean sources of energy as complementary to all other sources. So by the year 2034, we shall have our first nuclear power plant and grow it into 2036 and 2038 in that manner. Next slide. Now, when you look at our energy mix, 48% of our energy comes from geothermal, followed by 26% hydro. We have some imports from Ethiopia at 2%, Solar contributes 3% and wind at 14%. And Kenya boasts of having the largest in Eastern Central Africa wind farm that produces 300 megawatts. We also have this thermal. And this is our concern as a country because this is now a source of greenhouse gases, currently contributing 7%. And therefore, members, we foresee that by the year 2034, we shall replace this 7% with nuclear energy. And therefore, that means we shall have a clean source of energy, 100% clean source of energy in terms of our energy mix by the year 2034. So currently, our peak stands at 2,325. And there's something to note here as a country that this peak has been growing at a very steady rate. Last year, at a month like this, we were at 2225. Therefore, that means that over the last 1 year, we have grown our peak by a whopping 100 megawatts. So if we project this kind of growth, this again underpins our need to have a stable source of energy going into the Vision 2030. Our installed capacity stands at 3,300 megawatts. So all these sources of energy, as you can see, are critical to us, more importantly on the renewable sources. But you know that we need to complement each of these sources because they're important in their own rights. Renewable energy, you know, they have problems of intermittency, and therefore when you have a stable base load like geothermal, nuclear energy, and hydro, then we should be able to complement these sources of energy that we still have in our energy mix. We have high potential geothermal up to about 7,000, and also a lot of potential for solar and wind in our country. But this will work hand in hand with nuclear energy, providing the base load, which is sincerely required for purposes of industrialization for our country. Next slide. Now, Kenya is in the race, and we call it the African nuclear race. This is basically to complement each other and to work together. We shall never walk alone in this journey. We try to encourage each other within the African continent so that we synergize as we embark on the deployment of the nuclear energy. In phase 3, of course, the only African country with a nuclear power plant is South Africa. Now, Egypt is constructing its first nuclear power plant in phase 3. And in phase 2, we have Kenya, Ghana, and Nigeria. So, also we have a number of many African countries in phase 1. I'm happy to know that last week we were in Rwanda summit, which was talking about nuclear and innovation that we need to put in place to be able to increase our reliability, our access, and stability of the nuclear, of the energy sources in Africa. And therefore, in Africa, this race is on, and we are holding each other's hand to ensure that we work together and improve the access rate in our continent, to improve the stability of power in our continent, and also to improve reliability that will then attract industries to establish their manufacturing plants in Africa. And this will go a long way in providing the much needed employment opportunities to our young generation in Africa. Now, we are following the IEA milestone approach. And we have actually been evaluated in 2015 when we had our first in mission, and then follow-up mission in 2021. And that gave us a green light to move into phase 2, which basically now we are looking at the preparatory works for the construction of the nuclear power plant. And we have gotten a lot of support from IEA and other member states in regards to development of these critical infrastructure issues. And therefore, we shall continue to dedicate our time under phase 2 so that we can bring on board all the required infrastructure elements as we move into implementing the tasks within phase number 2. Next slide. Now, we have undertaken certain and made some achievement since the beginning of our program in Kenya. And in 2011, we had our first pre-feasibility study, and we have also established our regulator, which is a critical component within the deployment of the nuclear power plant in any given country. So we have an independent regulatory body with its staff ready to regulate the deployment of nuclear power plant in our country. We have also done our site evaluation and came up with various potential sites, which we shall be undertaking detailed site characterization. As a country, we also want to be knowledgeable in regards to the technology that we want to deploy. And in this regard, we have developed our reactor technology assessment, looking at all the available nuclear power reactors, both small modular reactors and the large nuclear reactors. We have also undertaken vendor readiness. This is again just to check the level of readiness of the available vendors within the globe in terms of their capital investment, in terms of their supply chain, in terms of their stakeholder engagement, and all that, and be able to rank our vendors in that regard. This all is in preparation for making a decision, so that as a country, we want to be knowledgeable in regards to the nuclear power plant. We have also undertaken strategic environmental impact assessment. This has been submitted to our environmental body, and they have given us some comments, which we are working on so that we can be able to resubmit back the strategic environmental social assessment. We have trained 127 Kenyans at master's level, both within our country and abroad. And this is a critical mass that we continue to train so that by the time we commission our first nuclear power plant, then we should have that critical mass that is required for purposes of design, construction, operations and maintenance, and into the decommissioning of the nuclear power plant. We also have some MOUs with the US, South Korea, China, and this is basically in areas of capacity building so that we can continue to develop this particular program. Of course, we have also developed our grid study, looking at what we have currently and whether it is robust enough to be able to evacuate the power that we are intending to evacuate from the nuclear power program. In terms of electrical grid, we have undertaken a detailed electrical grid study for our country, and we have noted some bottlenecks, which we have developed a master plan to be able to reinforce our electrical grid in preparation for evacuation of the nuclear energy from the nuclear power plant. We have also undertaken preliminary local industry readiness for our country, looking at the various components, services, and works that can be supplied by our local industries, and what are the requirements in terms of capacity building so that they fully participate in our industries. Of course, this value is still very low because we have only looked at the balance of plants and the capability of our industries to be able to participate. Next slide. In terms of our location of nuclear power plant, we have undertaken some regional analysis, the 3 regional analyses, and we have now 3 potential sites that we are looking at in terms of Kilifi, Kwale, and Siaya County. So these counties are the ones that we are now going to carry out a detailed site characterization so that we can confirm this particular site for purposes of the installation of the nuclear power plant. Next slide. So our next steps for our country as we get into phase 2 are ready to invite bids as our next milestone. We want to undertake a detailed site characterization in these 3 sites that we are talking about. And then we also want to complete our feasibility study for the deployment of the nuclear power program for our country, which is a critical input into the bid invitation specifications that we'll be doing at the end of our phase 2. Establishment of an owner-operator, you realize this is a very critical organization that is required for phase 2, and the government of Kenya is making every deliberate effort to establish this owner-operator so that we can synergize and move forward with the nuclear power program. Of course, the accession to the international convention, the 4 critical convention, also on the advanced stage, having been submitted for cabinet approval in this particular regard. We've also developed requests for information to the vendors, and this will be going out in the next 2 months. And this is basically to the various known vendors for critical information that can then be utilized by our country to make some decision as we go into the bid invitation. I think that then makes the end of my presentation, and I'm happy to be with you today. Thank you so much, and back to you.
Thank you, Engineer Ohaga. I hope I can be heard. And allow me to introduce our next speaker, coming from the Nuclear Energy Agency. We are privileged to be joined by Director General Mr. William D. Magwood IV to give a presentation on NuPEA and understanding nuclear power basics and benefits for Kenya. Mr. Magwood took up his duties as Director General of the Nuclear Energy Agency, NuPEA, on 1st September 2014. He has extensive experience in both the regulatory and development aspects of nuclear energy, including at the international level. From 2010 to 2014, he served as one of the 5 commissioners appointed by the US President and confirmed by the US Senate to the US Nuclear Regulatory Commission, NRC. While a commissioner, he served as global voice for the importance of nuclear regulatory independence and advocated the necessity of maintaining strong, credible, and technically sound nuclear regulation in the United States and all countries that use nuclear power. Prior to appointment at the NRC from 2005 to 2010, he provided independent strategy and policy advice to US and international clients on energy, environment, education, and technology policy issues. From 1998 to 2005, Mr. Magwood was director of the US government Civilian Nuclear Energy Program at the US Department of Energy, DOE. Without further ado, I invite DG Magwood to give his presentation.
Thank you very much. And it's a great pleasure to be with you this morning to talk about some of the work that we are doing in the nuclear area, but more importantly, just give you a global perspective on what's been happening around the world. It's a great pleasure to be putting this webinar together with our partners in NuPEA. I'd like to thank Justus and his team for the hard work in preparing for this, and we're looking forward to continuing this very important relationship. As you heard earlier, the NEA, which is a part of the OECD, is really the expert organization in nuclear energy. And we have member countries around the world that have the deepest expertise when it comes to building and operating nuclear power plants. In that respect, we have not been very active in Africa over the years. This is a new development. Our members have made it very clear they believe that the development of nuclear power in Africa is of strategic interest and importance to the whole world, and that therefore it's important that we be involved. And so that is why we launched the Common Journey Initiative, and that's why we are working with NuPEA today, and we're looking forward to continuing to do so. So again, my job is to give you a lot more of an overview of what's going around. And let me start with the first slide, which is very basic, which is where does the world get its energy from? You know, a lot of people hear a great deal about renewable energy, but the reality is that most of the world's electricity is generated from fossil fuels, still from coal, gas, and oil. But other sources are growing. Wind and solar have been growing around the world, particularly, I think, solar in many places. And I'll touch on that again. Hydro stays pretty stable. It doesn't grow very much. And nuclear has been very stable, providing 9 or 10% of the world's electricity for quite some time. But we're anticipating that this is going to change, and I'll talk about why that is. It's important to recognize that as you evaluate where to get your electricity from, there's many different factors that come into play. One factor, of course, is the impact on climate change. And if you go to the next slide, you see that one of the reasons that countries are interested in talking about nuclear is because of all the major areas of electricity production. Nuclear provides probably one of the most compelling stories when it comes to how to generate electricity without emitting CO2. Obviously, coal and gas emit quite a bit, far less from renewables like wind and solar, and nuclear is very competitive with all of those, as you can see here. So that's one of the reasons why nuclear is of interest. Another reason on the next slide is when you build nuclear facilities, they require much less land than hydro, certainly, but also wind and solar to get the same capacity. This is very important in many countries that don't have access to large tracts of land. And I'm going to come back to that point in a couple of minutes. Another factor to look at is the next slide. That's capacity factor. Now, this is actually a very important issue, that nuclear is available essentially all the time. More than for plants operating in OECD countries, it's typical to see those plants available 90–95% of the time. That means that when you need the electricity, the nuclear plant is there, it is producing, and it's able to dispatch this electricity wherever you need it, which is in contrast to renewables, which are available part of the time. And it's not that you can't deal with those variabilities, but it is a factor that you have to take into consideration. The next slide shows another factor, which is cost. People often point to nuclear as being very high cost, but the truth is that when you look at nuclear as a long-term investment, and you look at nuclear in terms of the capacity that is produced by the facilities once they're built, nuclear is a very good way of making electricity, a very cost-effective way of making electricity. In fact, analysis that we did a couple of years ago with the International Energy Agency showed that continued operation of existing nuclear power plants is really the lowest cost electric generation that you can get on the grid, and that new nuclear plants are actually quite competitive with other forms. And so cost, availability, use of land, carbon footprint, all create a compelling story. The next slide, however, shows that the reality for all energy forms is that there really is no magic solution. There's no perfect energy. While wind and solar have great benefits, they have their issues. While nuclear has great benefits, it has issues. And all of these have to be taken into account by governments as they make decisions about their energy futures. And that is really, in large respect, a big part of what you heard from Mr. Ohaga's presentation, as the evaluation that Kenya has gone forward with that has brought them to the conversation we have today. Let me make a few overarching observations on the next slide. When you look around the world, and not just with the member countries of the NEA, but really globally, energy security has become the driving concern of most governments. We see this very intensely with countries in Europe, in Asia, and many other parts of the world. And the fact that fossil fuel supply chains are very vulnerable to disruption creates an apprehension. And for many countries, the answer is to build nuclear power plants to secure energy, to make energies more secure. There's also a great need for new electricity generation. This is true in both the global south, where many people are coming out of poverty and they want to industrialize, but also in OECD countries. And in OECD countries, electricity demand has been very flat for many years, but now we see it possibly doubling over the next decade because of the need to electrify transportation, industry, to serve data centers and other needs as well. In responding to this increased electricity demand, we see that coal use is shrinking as countries decide to move away from fossil fuels for environmental purposes and other purposes as well. And in that respect, renewables remain very important, but countries have found that renewables are only a part of the solution. When you put all this together, the need to protect the environment, the need to have energy security, nuclear becomes very attractive, and that is why you see countries all over the world moving this direction. To give you a real live example as to why countries look at the need for both renewables and nuclear, let me show you a picture of a facility that is in the United Arab Emirates. This is a very, very large solar electric facility that applies both concentrated solar power. We can see the big tower in the background there. Next slide has a picture, a close-up picture of this. And it also has PV panels. So when you visit this facility, you will see row after row after row after row after row of these solar panels. And it's an incredibly impressive facility, very large capacity. And the capacity of this facility is almost as large as all the geothermal capacity in Kenya today. It's over a gigawatt. That's very impressive. The problem is that this facility produces electricity only 25% of the time. So you can imagine that when you're planning your energy resources, to have a big part of your capacity available only intermittently, 25% of the time, raises a lot of concern, a lot of issues, because you have to find the other 75% to deal with that variability. And another aspect of this, I mentioned land use. This facility takes 44 square kilometers of land. That's a very, very large tract of land for many countries. UAE, of course, has a lot of desert territory they can devote to this. But for many countries, it's very difficult to do that. And in contrast, a nuclear plant providing the same electricity would be available over 90% of the time and take only about 2 square kilometers. So that's why, on the next slide, you see that so many countries are now moving towards nuclear energy. And you probably have all heard about the declaration that many countries have made advocating a tripling of global nuclear capacity by 2050. This declaration was introduced during the COP process as countries were coming together to deal with climate change, and they realized that nuclear energy needed to be a big part of it. So the idea of tripling, which actually comes out of NEA analysis, has become very popular with many countries around the world. On the next slide, you can see that the current situation is that there are about 444 reactors in operation around the world, with 62 under construction in 32 countries. Again, about 9–10% of global electricity. So this is the picture today. But if we were to triple nuclear capacity, this, of course, would mean not just that we would have more reactors, but it means that more countries would be operating these plants. And we expect that countries in the global south will be a big part of this story. As you heard from the previous presentation, there is an effort in Africa today to move towards nuclear energy. Many countries are progressing through the IAEA milestones process to reach the point where they can build new nuclear power plants. Today, of course, there is very little nuclear in Africa. Only South Africa operates the Coburg plant, which has been in operation for quite some time. But many countries are very interested, and there's a lot of reasons for that. And let me talk about some of those reasons, which really echo what you heard previously. The big one, I think, is going to be energy access and security. The fact that so many people in Kenya and in Africa as a whole lack access to electricity is a major impediment to economic development. That's something that hasn't changed, and nuclear can certainly help with that because of the fact that nuclear is available 24 hours a day, 7 days a week, 365 days a year, and can be used not just in terms of large grid, but also can be applied to remote communities off grid. And this is something, if you can stay back on that slide, which is very important. Also, because nuclear plants emit no air pollution, you don't have the issue that you have with coal and other fossil fuels today, like burning charcoal for heat, where you really have a big impact on human health. Lung diseases around the world really come in large respect from burning of coal for electricity. And this doesn't even begin to talk about the issues of climate change. And finally, this is one that you heard from NuPEA, which is, I think, is extraordinarily important, that nuclear really does provide a tremendous opportunity for international development. And it is a matter of the fact that the nature of nuclear means you have to have people with the skills, both in terms of engineers and scientists, but also people who have the skills as welders and pipe fitters and other highly skilled professions, which are very, very highly paid. A good example is that to build a nuclear power plant, you have to have people that can weld the stainless steel. Jobs in the U.S. that where people can weld in stainless steel, you can have a starting salary of over $100,000 a year in the U.S. Just with that one skill. So it shows you how highly paid these can be, and how you can use this as a spur to economic development. And in addition, there's an opportunity, if the development is done in the right way, to build small and medium-sized businesses to support these projects. To move on to the next slide, you can see, I just wanted to highlight, because I know this question comes up quite a bit. What is nuclear power? So just really quick, I won't go into a lot of detail because we don't have a great deal of time, but nuclear really is the process of fissioning certain types of atoms, splitting them apart once they collide with neutrons to produce heat. The way to really think about nuclear is it's another way of heating water. That's really what nuclear is all about. It's really a way of using an advanced technology of nuclear fission to provide heat that can be used to boil water or provide steam for industrial processes. And this is something that has been going on for many, many decades in many countries. And if you go to the next slide, you see where this fuel comes from. The fuel is uranium. For the most part, it's available from around the world. There's many parts of Africa where you can find uranium. Without going into a lot of detail about this, uranium is mined, refined, and converted to a form called uranium hexafluoride, which can then be enriched in special facilities, of which there are only a few around the world, but they're globally available from different suppliers to produce this little black pellet you see here in this picture. This little pellet contains the same energy content as tons of coal. And you put these pellets in these metallic bundles, and they go into reactors to be burned. And that's really what nuclear fuel looks like. And when it's burned as nuclear waste, it looks very much the same. It doesn't really change. So you often hear, if you go to the next slide, that the nuclear waste is this sort of green goo that comes pouring out into the water. It's nothing of the kind. Those ceramic pellets stay intact in those metallic frameworks, and they're stored in pools like this one in this picture here for a period of years, and then eventually move to dry cask storage. That's how nuclear waste is stored today. It's managed very carefully. We know where every gram of nuclear waste is produced because it's required by law in countries and also on an international basis. And this is why we find that we can operate these plants very safely, because the nature of nuclear requires you to track these materials very carefully and to make sure that they're carefully stored. Eventually, this waste has to be disposed of, and the method that will be used are deep geological repositories. These are very, very deep mines where you deposit these materials and make sure they're isolated from the environment for really hundreds of thousands of years. And countries like Canada, Finland, France, and Sweden are really far ahead in opening their repositories. Finland will probably be the first in the world, and that will be operating later this year. Another aspect I wanted to touch on were small modular reactors on the next slide. This is a new type of reactor. Most reactors operating around the world are very large, complex machines. That are very expensive and take a long time to build. And today, there is a dream that is coming into reality to have smaller reactors. Reactors that are 300 megawatts or smaller that can be built in factory and shipped for installation onto a site. There are a lot of benefits to this, both economic benefits and quality benefits and safety benefits. And while I won't go into all these details, I'd be happy to answer your questions about this. This has opened up nuclear to more countries than would have ever been possible in the past. And this is something that I think is very important. It's something we're watching very closely. People who are developing these technologies really view nuclear differently than in the past. If you go on to the next slide, there's an organization called Third Way, which has been envisioning what these new reactors might look like. They might be placed in factories as part of industrial hubs. They might be in business centers near population centers or in remote communities. Just really a new way of thinking about nuclear energy. And this is very important because it isn't just going to be happening in OECD countries, but it's going to be happening in the global south as well. Now, when we prepared for this, I was told that there was a considerable concern about radiation. So I thought I would spend just a few minutes to talk very briefly about radiation, and I look forward to answering your questions about this. And again, we don't have time to go into a great deal of detail about this, but radiation is really energy emitted in the form of particles or electromagnetic waves as a result of a wide range of processes. Nuclear does emit what we call ionizing radiation, and this is something that is a part of the nuclear world that we are very familiar with. It requires us to provide for shielding and mitigation to make sure that this radiation does not impact workers or the environment. And we're very good at managing this. We understand it very, very well. And the truth is that this is an area of work and science and technology that's been going on for many, many decades. We know a lot about this. If you move to the next slide, I'll just sort of highlight that there are different ways of measuring radiation exposure, but you're most likely to hear the term sieverts. This is the quantity that's used to explain how the dose is absorbed by the human body. And there's a very complex set of calculations go into this, and we don't have time for today. But to give you an impression as to what this looks like, I'll go on to the next slide very briefly. And it shows that when you think about where we get radiation exposure, a lot of it comes from the natural environment. And this is a very interesting case of that. If you look at people who live in certain parts of the world, they receive radon dose. They get exposure from just the ground itself, which has certain rocks and materials that naturally emit radiation. And then there's also cosmic radiation. So whenever you fly on an airplane, you get exposed to a little bit more cosmic radiation. So in general, around the world, you receive about 2.4 millisieverts of dose just by being alive. And that's pretty typical. Next slide, just very briefly, again, shows what some of the effects of radiation can be. If you are exposed to radiation at higher levels, there are cancers that can develop. This is something that we watch and understand very well. But really, it takes a significant amount of exposure before you see these kinds of effects. The next chart shows an example of the kinds of doses that can take place from just normal everyday life. Going to the dentist gives you some exposure. Eating Brazil nuts gives you exposure. Eating bananas gives you exposure. But if you hit the next one, please, you can see that just the average dose to individuals in, for example, two countries here, UK and USA, show that you're at very, very small levels just by being around. And these are countries that operate nuclear facilities. And you can see that there's really no impact from living near nuclear plants on this radiation. If you work in a nuclear plant, you do get higher exposure. Hit the next one, please. And you can see that if you work in a nuclear plant, you're limited to 20 microsieverts of exposure, and that is still very, very low compared to the level of which radiation would actually have any physical impact. And that level is known to be about 100 millisieverts. So whenever you talk about the exposure to normal people, you're really talking about something that is an order of magnitude less than what happens inside of a nuclear power plant. And even what happens inside of a nuclear power plant is far less than what would actually cause human harm. Just to summarize all this, at the next slide, radiation exposure to workers in the public are very, very tightly controlled based on international standards and based on the best science. This is something that is watched very closely by regulators around the world. Levels of exposure that are experienced by workers in the public are not impacting human health. We have a long record of experimentation and assessment to understand that. And I think it's very clear that living near a nuclear plant does not lead to increased exposure. So there is not a risk of human harm by living next to a nuclear power plant. And even with nuclear waste, which is highly radioactive and has to be isolated, because we manage it so carefully, that it doesn't have an impact on the environment or on human health. And so this is something that we work on a great deal. Next slide. This is something that is part of a very vast international set of controls and frameworks. The IAEA, the International Atomic Energy Commission, International Energy Agency, has conventions and safeguards that really help countries protect against any harmful use of radiation. But then on top of that, there are coordinations. There's coordinations that regulators have with each other. For example, if Kenya were to start to operate nuclear power plants, they would have a regulator that would be part of an international framework that would work with the NEA, to work with the IAEA to make sure that they had the latest knowledge and the latest information, and that not only that they share information, but there be peer reviews to make sure that that each regulator is doing what it should do. And if they're not, they get called out very quickly. The same thing happens on the industry side. There's a group called the World Association of Nuclear Operators, which all nuclear operators belong to, and they watch each other very closely to make sure that they're being held to very, very high standards for safety. So nuclear is a global village. And as such, next slide, Kenya can start to be part of this village. But there are some things that need to be done. It's going to be very important for Kenya to build the policy and regulatory infrastructure. You've heard a little bit about that. That's underway today. For any country to make the right decisions regarding nuclear energy, ministries, industries, and others have to inform. They have to have the right expertise, and there has to be an independent safety regulator that's in place that has the right capacity to assure public health and safety. Kenya also will have to have very strong processes for public engagement, and this is part of that. That's part of what we do at the NEA. We support countries in having strong public engagement. We've learned a lot of hard lessons over the years on what happens with countries that don't have transparent processes. Decisions don't stand the test of time if you don't engage the public in a very, very substantive way. And we're looking forward to sharing our experience with people in Kenya. And finally, as you also heard from NuPEA, plans to how to finance and take advantage of the economic development opportunities of nuclear are going to be a big part of the conversation. A few final considerations on the next slide. We at the NEA have launched this Common Journey initiative to build cooperative frameworks so that countries in Africa can work together. And you heard that from Mr. Ohaga's presentation. It's very important that countries in Africa come together and share experience and share resources so that they each can move forward down this journey together, but also to cooperate the frameworks within OECD countries that have this very deep experience. That's something that we're very focused on, and that we're going to be looking at how to build the capacities in ministries and legislatures to make the right decisions, to build skills and education, to support strong public engagement. And also a big part of our effort is encouraging women to participate in nuclear science and technology. And that's because when we look around the world, we see that women are often not part of the nuclear conversation. And we're trying to fix that in OECD countries. And we think it's very important to encourage that in Africa as well. My last slide, just some final thoughts. International frameworks provide a very, very strong system of knowledge sharing, standards, and peer review to assure nuclear safety in countries. This is how it works in all countries around the world. Everyone is watching everyone else because there's a clear understanding that a nuclear accident anywhere is a nuclear accident everywhere. Therefore, every country that operates a nuclear power plant has a very strong interest to make sure that other countries are doing the right thing. And there's a lot of frameworks in place to make sure that happens. Nuclear energy also requires very rigorous processes, legal frameworks, oversight, and practices. Otherwise, no one will ever sell you a nuclear power plant. It is just that simple. There's too much risk for the suppliers to sell nuclear technology to countries that are not ready. So that's why they watch the milestones process very closely to make sure that all the right parts are in place to support a nuclear program. And that's very, very important to everyone in the entire nuclear sector. And one last observation I would make is that we have seen in many cases the fact that nuclear is so disciplined and benefits from so much oversight that this can create a spillover effect in other parts of society. And so it isn't just benefiting just the nuclear sector, it can benefit other sectors of industry and society as well. And so this is something that we look forward to working with Kenya to take full advantage of. And again, I appreciate the cooperation with NuPEA and look forward to answering any questions we have today. So with that, Lily, I hand the floor back to you.
Thank you, DG. Thank you, Engineer Ohaga, for your presentations. I'm sure everybody has been able to get some clear understanding and inkling on what we are looking at. So at the moment, we're about to move to the fireside chat. So DG and the CEO, there's some questions which we'd like quickly, which you can address to the CEO, Mr. Justus. So why nuclear and not other sources of energy that we have in Kenya, such as geothermal, solar, and wind?
Thank you, Lillian, and thank you, DG Magwood, for an excellent presentation, and also Engineer Ohaga on very, very insightful positions placed about Kenya's nuclear program. Lillian, to your question, let's be clear that nuclear is not competing with the other clean sources. Kenya is considering nuclear because of some of the reasons that we've heard from the presentations of DG Magwood and Eric. We are saying that we want to be energy secure so that we are able to meet our economic needs without compromising the opportunity of future generations to meet their needs by endangering the environment. You saw from Engineer Ohaga's presentation the 7% dirty sources of energy that we have. That is a goal that we are aspiring as a country to address so that we have all our sources being clean. So in regard to the fact that Kenya is generating over 90% of energy from clean sources, we are really thankful for that and grateful for that. But as we saw from the presentation of DG Magwood, when you look at solar, there's the aspect of taking up a lot of space. and also the fact that it is not available throughout, it is intermittent. The same thing applies to solar. And as we aspire to become an industrialized country, we need stable baseload that can support our industrialization goals, so that we are also able to generate affordable electricity, which will encourage investors to come back to town, so that we are able to build more industries and generate more jobs in our country, and ensuring that we do value addition, so that we move away from what has been happening traditionally, where Africa tends to export raw materials very cheaply, and importing back finished products very expensively, and that causes a lot of drain on our sources. So we are looking at nuclear not to compete with the wind and solar and hydro, but to complement those other sources, so that we have a rich mix that will support our industrialization goals without compromising the safety of the environment. Thank you, Lillian.
Thank you, Mr. Wabuyabo. There's one more question that has also come in. So why Kilifi? Why CI for the nuclear power plant sites?
Yes, why Kilifi, why Siaya? Maybe we should add, and why Kwale? The process of identifying locations for building nuclear power plants are very rigorous. In the presentations that we've received this morning, you will have noted that there was a lot of talk about safety and security, and we all know that even on a personal level, if you want, if you have land and you want to build a house or a hut, you don't just wake up and build it anywhere. You have to do some survey and determine what is the best location that you want to locate this structure that you want to build. It is the same thing for Kenya, that when we made the decision to build a nuclear plant, we have to ask ourselves, where is the ideal place to locate this infrastructure? And there are a number of things that are looked into. First of all, and is normally a key consideration, is that nuclear power plants require a lot of water for cooling. And therefore, you want to locate this project near a large water mass that can provide that water for cooling. Then you also need a stable place, a place with a stable rock that will ensure that you building it on a strong foundation. That's another consideration that you look at. There's also the logistics bit of it. The equipment that will be used to build nuclear power plants will require transportation, and therefore you need to locate the plant in a place that you will ensure that you will be able to deliver those equipments without a lot of trouble. But also, once the plant is built, you need an easy access for purposes of emergency planning and emergency response. So there are a number of considerations that go into determining the location of the plants. So what we did as a country is that between 2016 and 2019, we did a survey of the country and did some mapping and identified these 3 locations as the best locations that we would like to site our nuclear plant. And therefore, Kilifi, Kwale, and Siaya were identified as the possible sites that we could do this without a lot of difficulty. But that is not to say that the final decision has been made. Once we did this siting, we are going to undertake site characterization in carrying out more studies to determine the full suitability of these sites before the final decision is made. So we'll have consultancies that will come to do detailed studies. We'll have to study the weather patterns of these locations, the same seismic conditions of these locations to make the final decision. So that is what we are doing at this stage. And I want to assure everyone that we will do this following the best practices around the world, getting a lot of support as we've done throughout the process from the international body that regulates nuclear around the world, that is the IAEA, and with our new partnership with NuPEA, which is bringing to us an opportunity to have a chance to get the experience from countries with very advanced technology and experience in these areas. We should be able to learn from them as we undertake that activity. Thank you, Lilian.
Thank you, Mr. Wabuyabo. Over to the DG. Just two questions for you as well. So will the nuclear, in terms of the people who host the power plant, the community that will host the power plant, will the nuclear plant negatively impact local social activities such as fishing, farming, and what role does it play, and also tourism? Which are significant sources of livelihood for people living around those areas?
That's a really interesting question, because it really depends on a wide range of different factors that I think that you heard from Justus just a few minutes ago. When you're assessing where to build a nuclear power plant, you do have to take into consideration how it affects the local economies and the local situation. And for example, if you had an area that was that got most of its economy from tourism, you might decide that that's not the best place to put a nuclear power plant, not because it will scare away the tourists, but because you want to use that land for hotels or something else. So I think all these things go into consideration. But as a general matter, I think it's fair to say that the experience over the years in different countries has been that building a nuclear power plant does not have a big impact on, say, fishing or farming or areas like that. In fact, there are certainly parts of the world where the fishing is actually improved by the nuclear power plant, because nuclear plants make the water just a little bit warmer and the fish like that. So I think it's fair to say that there is not a big impact on issues like that. But it is part of the consideration that has to be taken as sites are identified.
Thank you, DG. One other concern that we've faced or we've had from our stakeholders is, what are the health impacts of people who live near a nuclear power plant? Can they safely live near it? And for the people who are working in a nuclear power plant, how safe are they?
Yeah, as I tried to mention very quickly, it's extraordinarily safe. I mean, I think that the workers who are in nuclear plants do receive a little bit higher radiation exposure than the general public, but it's not enough to cause any harm. It's far short of where it would cause harm to individuals. So working in nuclear power plants is very safe. I have visited many nuclear power plants around the world myself, and been in radiation zones. And all these years, the doses that I've received have never been of any concern. And so it's something that that I think requires some public education to explain that how we control radiation, what actually takes place in a nuclear facility. And I actually recommend that whenever possible, in fact, this is something we've been talking with NuPEA, that people visit nuclear facilities so they can see exactly what it's like to be in a nuclear facility. And for the general public, there's really no impact at all. We have seen many studies over the years looking at whether there's a health aspect to living near a nuclear plant, and no one's ever found anything to show that there was any health impact from living near a nuclear power facility. And in fact, in most communities that host nuclear plants, the people who live there are extraordinarily supportive of having a nuclear plant. because they recognize the benefits in terms of economics and job creation and things like that. And so yeah, the experience we have really shows no human health impacts.
So just an addition, given your experience, how does the international community ensure nuclear safety for a country such as Kenya, which is now introducing its nuclear power program?
Well, certainly, as you heard, the IAEA works very closely with countries like Kenya to help make sure that that the right pieces are put in place. But once the country comes into the nuclear field, then that opens up this whole village of interaction. We work with countries that are not necessarily OECD member countries to share our knowledge and share our information and invite them to our discussions so that they can hear firsthand what the most expert countries are doing to solve different problems. Countries around the world are very generous when it comes to supporting others who would ask for support in solving particular issues. So if there is a technical issue, the nuclear power plant that operates in a country like Kenya, there are many countries that will come to assistance to say, here's how you solve that problem. We'll be happy to send people to the plant to give you advice. There's a big infrastructure to support the operation of nuclear facilities, both on the industry side and also on the regulatory side. And you will certainly find that the community is extraordinarily proactive. In fact, to some degree, there's a lot of peer pressure to make sure that operators of nuclear facilities are holding very high standards, because as I mentioned, there is a clear understanding that if there's a nuclear accident in any place in the world, it affects everybody else. So there's a huge amount of incentive for operators and regulators around the world to work with particularly newcomer countries to make sure that things are done the right way and that they're supporting nuclear safety within that country. It's very important to everyone.
Thank you, DG. Thank you, CEO, and also thank you, DG, as well, for answering some of these questions, which brings us to the end of our fireside chat questions. Now, I would like to pose the questions which we have been receiving from the public, and I would request the CEO, Engineer Ohaga, as well. Please, I will address each as they come in on who can answer. Okay, so first and foremost, there's the issue of wind and solar, which we have already addressed for the CEO. Has NuPEA also contracted Finland in waste repository being the best currently?
Thank you, Lillian. In regard to engaging Finland, I think what I will say is that we must be very clear that Kenya does not have a nuclear plant at this point. And as was presented, you will see that in regards to management of the nuclear waste, that can be retained in the plant during its lifetime, and at the conclusion, then that can be taken and taken to the final repositories. What we need to say is that Kenya is following a milestone approach designed by the IEA. We take consideration of the issue of management of radioactive waste from the beginning. When we'll get to the point of onboarding the technology, that's a conversation we will have. But it will be interesting just for the audience to know that the president of Finland was in Kenya some time back, and they had a conversation with our president, and I know for a fact that they had some discussion about nuclear, and our president had a lot of interest in that. And I believe that when we get to the point of implementing our program, Finland and other OECD countries are some of the partners will be engaging and having a conversation so that we can learn from them and get experience from experience from them and see how we can partner with them to address that issue. But also that said and done, we, as DG Magwood mentioned, the nuclear fuel is generated by a few companies, and at the time of us making the decision on the technology, we will have a global conversation of how to address the issue of nuclear waste. Thank you.
If I can add,
CEO.
if I can add, I think that explanation was very good. But let me also emphasize that nuclear waste has always been a challenge for all countries that operate nuclear facilities, and it's not because we don't know what to do. We absolutely, the science and the technology is very clear on how to manage and dispose of nuclear waste. The challenge that countries around the world, including my home country, the US, have often faced is creating the right public policy process to select the site. That's actually the hardest part. And countries like Finland and Sweden and Switzerland and France have really done tremendous work to show people how you go through this process. And what we've learned over the years is that countries, when they are moving towards disposing of their nuclear waste, they simply have to do the homework. They have to have lots of dialogue and discussion with communities and with individual experts and universities in their countries to begin to answer questions. And this could take years. It's not an easy process. It can take a decade before you reach the point where you're confident, you build the confidence that you can locate the nuclear waste in a site. But science and technology tells us we know how to dispose of this safely. It's a matter of finding the right sites and working with the public to identify those sites. That is really the challenge.
Thank you, DG. Over to Engineer Ohaga. There's a question on what initiatives are there for graduates and postgraduate students in multiple activities within the power program? And does Kenya have critical mass in the form of nuclear scientists?
Thank you so much, Lillian. And I think I also need to add my voice on the RAD waste management before I get into the competency levels. We have developed and made a lot of benchmark with Finland because of their site at Onkolo and our infrastructure issue of RAD waste management. We developed a strategy looking into the future, of course, after deployment of the nuclear power plant, and most of the reference we got from Finland, and therefore we consider Finland as a major country because of that breakthrough, and we continue to make reference to Finland when we are developing our RAD waste management policies and strategy. Even this financial year, when we developed our technical criteria and requirements for storage of spent fuel, we made great reference to Finland as our reference point in regards to RAD waste management. Now, in terms of the critical mass, and this has been a steady flow. I remember in 2012, when we started this particular program of capacity building at master's level. Currently, we stand at 127, and 68 of these people have been trained abroad in South Korea, in China. And we have another 68 who have been trained here locally at the University of Nairobi, Institute of Nuclear Science. So with this 127, we want to continue to develop them in regards to the on-the-job training and secondment, so that we continue to appraise them of any development that comes their way. But the strategy that we have developed in terms of human resource for Kenya, for CSAs making steady progress in terms of developing these competencies every year. We have in Kings, this is South Korea and also China, a number of about 10 every year. And also in Kenya, next year, we shall be commissioning the Kenya Institute of Advanced Technology, which is a mirror to the South Korea Institute of Advanced Technology. And they will be training more nuclear engineers, more scientists on this. And therefore, with our target date of 2034, we foresee that by this date, we should be able to have the required competencies to run the nuclear power program. Over to you, Lillian.
Thank you, Engineer. To DG, we have a question from Burkina Faso. So in relation to SMR, how can we ensure the development of Africa, and what are its strengths and weaknesses?
Specifically with SMRs, I certainly think that whether you build SMRs or more traditional technologies, it always starts with having the infrastructure in terms of the nuclear regulator, the administrative decision-making processes, the skills that you just heard about. Those are still important. And I think that for small modular reactors, you still have to have all those capacities, but you probably can have a little less need for experts than you would for a large nuclear facility. It's less complicated, requires fewer people to operate. The vision certainly is, if you operate a large nuclear power plant, you probably need depending on the plant, more than 500 people to operate the facility. For an SMR, you probably can operate most SMRs with less than 100 people. So just the numbers of people necessary to operate the plant will just be smaller. So for countries that are coming into this for the first time, SMRs make a great deal of sense because it gives you a place to start and to be able to have real capacity with real nuclear operations, but on a smaller scale. Which really makes it easier to deploy. It's a smaller economic burden because a large nuclear power plant is being built in the UK right now, for example, is now costing something north of 25 billion pounds. That's a lot of money. An SMR will not cost anywhere near that. So from a financial standpoint and human capacity standpoint, SMRs present a much more realistic picture for most countries with small grids and smaller economies.
Thank you, DG. Just about to conclude, to the CEO, there's a question on Kenyan youth and how we can engage them better to ensure that their voice is heard and consulted and in a meaningful manner. This is also tied to the question on how do we want to assure the community about the safety of nuclear power plants to reduce their worry, address their concerns, and to engage them in the NPP implementation to ensure that it is accepted.
Thank you, Lillian. I think for the young people, they're really the future of Kenya, and the strategy of the government is to start constructing the first nuclear plant in 2027. And when we look at the experience around the world, nuclear power plants take maybe 7 years to construct. Of course, now with the SMRs, that could be shortened. And therefore, when you look at it, I have a son who is 23 years, and I see he will work more in this space more than me, and therefore the young people are really the people who will drive this for Kenya. And in our strategy, we have made a deliberate move to involve them. In Kenya, we have the Kenya Young Generation in Nuclear, KYGN. And as NuPEA, we've really supported them, and we support the activities, and we want to really involve them in a lot of the activities that the country is doing in this program. Engineer Ohaga mentioned about developing human capital. What we've done is that we've focused on the young people when we're looking at opportunities for training. We are looking at young graduates so that we are not training people who are approaching their retirement age, because they will not play a very, very useful role in the program. And therefore, we want to say that we will involve the young people in this process to ensure that they get the right skills to be able to work in this space. Part of the HRD strategy is that we want to work, and we've had a discussion with the DG Magwood on this. We want to develop a program of training, doing this training back at home, and that will guarantee more numbers under the program of training of trainers. And we've also had an engagement with some American universities where we want to work with them so that we are able to develop a curriculum for nuclear training programs in our universities in Kenya and TVETs, and that target will really be young people. So I want to encourage the young people out there, and the opportunities are many, and nuclear supports literally all professions. Whether you're a welder, you're a plumber, you're a mason, or you're a lawyer or an accountant or an economist, there is really room for all professions in the nuclear space. So we want to encourage the young people to start looking for opportunities. And as my office actually also doubles as a national liaison office for the IEA, and we have a lot of training opportunities that come around, and we will make these available to the young people so that they can take advantage of them. Thank you.
Thank you, CEO. To the DG, one small question on cost. Some are considering that nuclear power plants are costly in terms of building and also implementing. How can you please address this issue on investing in a power plant and its costs, its high cost issue?
Certainly. I mean, if you look around OECD countries over the last 15 years, you see these very, very high costs to build nuclear facilities. And there's two reasons for that. One is that OECD countries, in large part, have not been building nuclear plants for a long time. They're really getting back into the business of doing that now. And building a nuclear power plant is a skill, a practice, that requires a lot of people to understand the job they have to provide. And in many of our countries, we've lost those skills over the years, and we have to rebuild them. And when you are starting to rebuild, you're going to have higher costs and more delays, and that's exactly what we've seen. However, now we've been through these projects in the US and France and Finland and other countries. And so every time you go through this, you build more capacity and more skills, and the next project will be better and easier and cheaper. So part of it is the fact that we have been out of practice. That shows these numbers to be very large. But with small modular reactors, we certainly have the aspiration that because much of the reactor we built in a factory and shipped to a site, that they are much, much easier to build and the cost be much more predictable. So we really fully expect that by the time the countries like Kenya are in a position to build these facilities, that the costs will be very well controlled. They will not be as expensive as what we've seen in the newspaper headlines, and that these will be very manageable projects. That is absolutely our expectation. And I have a lot of confidence that we'll be able to realize that.
Thank you, DG. To Engineer Ohaga, there's a question on how does NuPEA offer or support training or capacity building initiatives aimed at developing nuclear law expertise? And an additional question to that, which you can answer, is on the issue of what are the far-reaching implications for neighboring countries, especially with the issue of CIA? This is regard to Uganda, Tanzania, Ethiopia, Rwanda, the geopolitics of this.
Thank you, Lillian, for that question. As we have stated in terms of human resource development, which is a major infrastructure issue for us, and we pay a lot of attention to it, and this does not exclude the legal fraternity. We have, of course, nuclear policy, energy policy that we have been able to even send our legal team to undertake at master's level. And more importantly, within the IEA, where we have short courses that are aimed towards sharpening the skills of our legal team. And this happens every single year. So this is a very critical aspect because we know the legal framework, the regulatory framework is a key component of our infrastructure issue, and we require this expertise for purposes of ensuring that that confidence level is maintained within our country. So there are several opportunities. There's a School of Legal Writing, regulations that are available for our lawyers to undertake and also sharpen their skills. In regards to the geopolitics of the SEA location, and these are major stakeholders. As you are aware, within the Eastern Africa, all these countries are considering deploying nuclear program. Uganda has a very high support from the very top, and that is the presidency. And of course, the geopolitics and also the shared resource of the lake can never be underestimated. So as a country, we have been working and we shall continue to consult across East Africa to engage all our stakeholders at the political level, at the presidency level, so that this program can be a success. We know that in terms of even logistics of these countries, we require each other for the success of this particular program. So that is a major consideration that we are looking at our stakeholders engagement strategy. We have made a deliberate effort to ensure that we reach out to our neighboring countries for purposes of them giving their views on the best way forward to implement this program across East Africa. Thank you, Lillian.
Thank you, Engineer, for that insightful.
Can I add to the nuclear law? Because this is a really important point. We have found that nuclear law expertise is actually in short supply all over the world. It's a major issue that we at the NEA are dealing with. We have begun work with the Global Forum on Nuclear Education to rebuild nuclear law capacity in universities around the world. Certainly we'll look forward to working with Kenya to pursue this. We have had people from Kenya attend the International School of Nuclear Law at the NEA, which I think has been helpful. But none of these international short courses are sufficient. You really have to build capacity at home. And so we're going to have to really look for ways to work with Kenya universities to build nuclear law capacities in Kenya. That is really going to be the solution. But this is not just a Kenya problem. This is a problem really all over the world, and it's one that people are beginning to wake up to. So I'm really pleased that someone asked that question.
Yes, thank you, DG. Before Engineer, there was a question also aligned to, is there a plan to consider the local community in the job employment for the program?
Thank you, Lillian. And this is important to us because the local community are the ones who are going to host these nuclear power plants. And when you look at the benefits associated with this project, it actually emanates from the local people. And when we design our programs and projects will involve the local people so that they can directly benefit from this project. And therefore, we say that in terms of giving preference, because this is localization, preference will come from the host counties so that their capacities can be built in the various areas that they are good at. And then eventually when we start our construction, operations and maintenance, their host community will be fully engaged in that particular regard. So we have various opportunities for the people living around the nuclear power plant at the craft level, at the diploma level, and also at graduate level. So each one of them will be able to have an opportunity to provide services to the project. Thank you.
Thank you, Engineer. To DG, there's a question on nuclear security and mostly important about the nuclear power plants and how can we be able to make sure that there's no external attacks, strategic liability in the event of internal conflicts, cyber attacks, or future geopolitical confrontations, which our engineer has answered. So how is nuclear security guaranteed for a nuclear power program?
Very, very important question, especially these days, I think. When nuclear facilities are built, they are built with security in mind. They are designed to be secure from external assaults, from terrorist groups or from cyber attacks. It's part of how they are designed and how they are built. That said, I mean, there are certainly there's certainly the concern that people have had, particularly in watching the situation in Ukraine. What happens if there's a conflict? How do we deal with that? That's a very important question. I don't think there's a very specific answer to that. I think it's very situational. It depends on each individual country's political situation and neighbors. But in general, we find that among the facilities that are operated in a country, the nuclear plants are the most robust and the most able to deal with the unexpected. And I think you're going to find, particularly with new small modular reactors, that they are built with even worst case scenarios in mind. Many of them are going to be subsurface, for example, in order to protect against attacks. But it is a concern that I think everyone has to be very conscious of as we go forward. And I think this is something that after watching the situation in Ukraine, I think we're all much more conscious of than we were in the past.
Thank you, DG. And finally, to our CEO, what is the role of universities and research institutions centers in this project? Or this program for the proposed sites?
Thank you, Lillian. I think universities are training grounds for human capital, and our strategy has been very deliberate. In regard to our program, as we mentioned earlier, we have identified 3 sites, that is Kwale, Kilifi, and Siaya. And thankfully, in those regions, we have universities, and our strategy has been very deliberate. We have already signed an MOU with the Pwani University, which is in Kilifi County. And as we also make engagement in Siaya, we are going to be concluding an MOU with the Jaramogi Odinga University of Science and Technology, which is also in the region where the Nyanza site is, because we recognize, and we've seen this, because when you look around the world, when you go to Korea, you will find that the King's University is really sponsored by KEPCO. In China, Tsinghua University has the engineering programs which are sponsored by the China's leading nuclear companies. And I believe that is similar to other jurisdictions. And therefore, we'll do partnerships with universities so that they will be training grounds for future workers in the nuclear plants. In regards to research institutions, again, we recognize the role of technical support organizations, and we'll also be working very closely with them. In Kenya, the National Research Organization, NRF, is a state corporation, and we've also already concluded an MOU with them to have that partnership, because there'll be a lot of research going on around nuclear issues, and there'll be intellectual property issues arising, which will require to be addressed, and therefore a collaboration with research institutions will be very critical. So we'll deliberately pursue those collaborations to ensure that any issues around human capacity development and such issues are addressed within those appropriate forums. Thank you.
Thank you, CEO. Engineer Ohaga, there's a question on cost. I know the DG had talked about cost. For this one, it's more of how is NuPEA addressing the cost perception and positioning nuclear as a viable part of Kenya's energy mix.
Thank you so much, Lillian. When you look at the Kenyan case, and when I look at nuclear power program, it's like a marriage, more than a marriage of a century, and actually supports like 3 generations. And therefore, when you invest in nuclear power program, you're investing for 80 years, and you can even extend it further to 100 years. And when you look at the complementary of other sources of energy, where we know that for solar or for wind or even for geothermal, that have a design lifespan of 25 years. After the 25 years, you need to decommission them and reinvest afresh in those power plants. Now, if you have, for example, 1,000 megawatt, one nuclear power plant operating for a century, and you have a solar plant operating for 25 years, and you need to decommission it after 25 years and reinvest afresh for another 25 years, which is 50 years. So that means in 100 years, you will have invested 4 times if in the case of solar or wind, which has a design life of 25 years. So if you look at the leveraged cost of energy emanating from nuclear power plants, given that long period of time, shows that at the end of the life cycle of that nuclear power plant will cause a reduction in the leveraged cost of energy. And that is what is bringing about that benefit of competitiveness in terms of cost for a nuclear power plant. And therefore, I think that we will make sure that we are able to disseminate this information, because these are facts that are known in terms of complementing the overall cost of any given country if you want to ensure that your citizens can enjoy a reduced cost in terms of energy. I submit to you. Thank you.
Thank you, Engineer. So finally, one last question. There's so many questions today, but I think the DG can address one last more to Director Magwood. In supporting newcomer countries like Kenya, how is NuPEA working to bridge the gap between international nuclear standards and local implementation challenges, particularly around public acceptance, infrastructure readiness, and long-term financing?
Well, I think that is certainly why we're here. We're here to see where the expertise has been generated in OECD countries over the last 50 years can be brought to bear to support the work in Kenya. And the NEA acts as a repository of this knowledge and information, and we intend to share this very openly with NuPEA and our colleagues in Kenya, because we think that this is extraordinarily important. I mean, really, many of the questions you were asking in the last few minutes, I think, really play a big role in this. For example, when you talk about how do you assure that local communities participate in the economic aspects of a project, and how do universities participate? It requires planning. It requires a lot of careful thought. And there are so many good examples in OECD countries where the opportunity of building a nuclear power plant was seized to create small businesses, to create programs at universities, to educate young people, to build skills and capacity. And there's a lot of direct experience that can be shared with Kenya on this. So that's really what we are here for. We're going to share that knowledge and share that wisdom and experience. And it's not that we're brilliant people that knew all the answers. It's just we've already made all the mistakes. And that way we can tell you where OECD countries have learned from the hard lessons of the past, share that experience so that as this program goes forward, that you don't have to make the same mistakes that we made, and that therefore you can move forward a lot more quickly and efficiently. And I think that because there's such an opportunity and there's time to do this right, there is the prospect of having very, very successful programs in countries like Kenya.
Thank you, DG. Thank you, CEO. Thank you, Engineer Ohaga, for answering the many questions. There are many more, but we will try and provide this so that we can get some answers and also post them for our stakeholders. Unfortunately, our time is coming to an end. I would like to thank our speakers for the Q&A session, Engineer Ohaga for his presentation, and to the audience for your strong engagement. As Kenya progresses towards the development of the nuclear power program, public education and awareness is essential to enhance your level of awareness and knowledge. It is our central point. It is one of our mandates, and it's something that we are heavily investing in to ensure that you become knowledgeable and understand what this program means for us, for our future, and also for Kenya. Thus, NuPEA is committed to fostering transparent and informed dialogue relationships regarding Kenya's NPP. This webinar was aimed at enhancing awareness on what nuclear energy technology is and Kenya's current nuclear power program. And also, one of the commitments we have made is to ensure that we demystify common myths and also address common questions that we have actually received, given from our many engagements that we have had. This is not the end. We will still have more opportunities to ensure that all stakeholders' voices are heard, and we will consult with you in case of any questions that you may have. You can address them, and also you can come to our offices at any time or address us through our social media platforms or also the website. We are available to answer your questions, to address your concerns, and to make you feel more comfortable about the nuclear power program. So thus, after this is the first in a series of webinars that we will be hosting. It's not the end. We hope that you'll stay tuned and you'll continue to follow our informative webinars on nuclear energy, bringing together international nuclear expertise and local perspectives. After the webinar ends, kindly take a short moment to do a survey, which will appear after. We will greatly appreciate if you could stay on and take a moment to complete it. And it is beneficial for us to ensure that we provide information that is what you require and is relevant to you. Thank you for your time, attention, and everybody have a wonderful day.